example 4. Use substitution to find the indefinite integral. The integral of z times the square root of 5z squared plus 6 dz. So remember that square root is just an exponent. So let's make this into a power function. So it's 5z squared plus 6 to the 1/2 and then times dz. So normally, or most of the time, the interior of whatever's being raised to the power is going to be our u. So we'll call that our u. And if it doesn't work, we'll back up and try something else. U is 5z squared plus 6. So the derivative of u with respect to z is going to be 10z. I want something that I can put in for dz. So I need to get this dz by itself. So I'm going to multiply by dz, both sides. That's going to give me du is 10z dz, and isolate that dz by dividing by both sides by 10z. So the 10z's will divide out. I'll get du over 10z equals dz. Now, again, don't be worried about the fact that you have a z in your u expression. That's fine. It's going to work itself out if we pick the right u. So I'm going to only put in what I have, something I can substitute for. So I don't have anything that I can put in for a plain z. I have a u to the 1/2, right? Because 5z squared plus 6 was my u. And I do have something for dz. It's du over 10z. Now look, all of these are over 1. So since this z is in the denominator and that z is in the numerator, that just took care of our z's. So I have the integral. I haven't taken the integral yet, but I've got it simplified down to the integral of u to the 1/2 du. So that's going to be u to the 1/2 plus 1 divided by 1/2 plus 1 plus c. So that's going to be u to the 3/2 over 3/2 plus c. When you divide by a fraction, it gets inverted and multiplied. So that's 2/3 u to the 3/2 plus c. And now all I have to do is put this original expression for u in for that u, and I'll be finished. So it's 2/3 5z squared plus 6 to the 3/2 power plus c. That is my final answer.